أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. I'm Dr. Muslim Khan, Assistant Professor, Department of Chemistry, KUST. Today, the topic of our discussion is sampling in analytical chemistry. The course code is CHEM351. So, first of all, sampling is a very important factor when we use analytical method. So when we use analytical method to solve a problem, there is no guarantee that will obtain accurate or precise results. So your sampling is one of the most important factor which decides your accuracy and precision. So in a designing an analytical method, we consider potential sources of determinate and indeterminate error, and we take appropriate steps such as reagent blanks and the calibration of instrument to minimize their effect. Why might a carefully designed analytical method give a poor results? One of the possible reason that is we may have failed to account for errors associated with samples. If we collect the wrong sample, like if we collect the wrong sample, or if we lose analyte when we prepare sample, this collected sample for analysis, so then we introduce a determinate source of error. If we fail to collect enough sample, or if we collected sample of the wrong size, then the precision of our analysis may be may suffer. So here in this lecture, we are talking about more how we can get uh, the representative sample which can represent the whole bulk of population, a small sample size which can represent a bulk of population. So the importance of the sample is so, but the sampling and method of analysis, so type of analysis depend on the size of the sample. So type of analysis, so if we are looking for the sample size, if we are doing point like micro analysis, we need a sample size of 0.0001 gram. If we need to do a micro type of analysis, we need 0.001 gram of sample. For a semi-micro, we need in between zero point zero 0.01 and zero point 0.1 gram. And for macro type of analysis, we need zero point 0.1 gram of sample. So this sample is sample size. Basically, you are taking it according to the type of analysis, whether it is needed ultra micro, micro, semi micro, or macro type of analysis you need. So what is sampling? Sampling is basically the the sample you want to analyze. So how to achieve a sample for analysis? Achieving sample for quality control. Analysis depend upon your sampling. The method of sampling is very important. So a number of types of samples. One is the grape samples and grass samples, representative samples, analysis samples, and laboratory samples. So a grape sample a- of a single sample taken at a specific time. This is the most common and easy type of sample. For example, you take a grape sample when you collected a beaker of raw water and tested it for pH. For example, there is a running water of river. You want to you want to measure the pH of this running water, or you want to measure the dissolved oxygen, or you want to measure the total organic matter, or you want to measure the total residual chlorine. So you just go there and collected randomly a sample from this running water by a beaker. Grape sample usually provide an immediate, this is an immediate sample that immediately you want to know the pH, dissolved oxygen, total dissolved matter, or total residual chlorine, etc. So this is usually preferred for a quick test for pH and all those things what I mentioned it. If the individual sample do not represent accurately the population from which they are drawn, a population that we call the target population, so therefore a much uh, careful sampling is necessary. So it may not completely, so this grape sample may not completely representative of the entire flow, but the best thing for this even grape sample to represent a bulk of your bulk representation. So several take a several grape sample at a different time in the same location. For example, one you take it 9 o'clock, other you take it 12 o'clock, other like 3 o'clock, other 6 o'clock. Then like means some means let's say 100 ml from this, 100 ml from this, 100 ml from this, and 100 ml of this combined to form a composite sample. So a composition of sample may vary with time, place, or environment. So that's why for a grape sample, you should take this several grape sample at a different time and then mix these samples with each other, but in the same location, because the composition of sample may vary with time, place, or environment. So grape sample must be collected carefully to make them as representative as possible. So mixing two or more grape sample may not give result which averages the characteristic of a sample. So representative sample is a small quantity of something such whose characteristic represent accurately as possible the entire batch, lot, population, or universe. Small size, composition similar to a whole number of grape and sample mix. Usually, this type of this type of sampling plane or sampling technique is used during the sample. First of all, gather material into a cone. This is a very typical way how to take a representative sample from your bulk population. Gather material into a cone. Then what you should do with it, then flatten this cone and then divide this cone in a half and then divide into a quarter. So discard three of the quarter and take one. Then this fourth quarter is again is again making it into a cone like this, and and making cone and make it flatten again, and then divide into a half, and then divide into a quarter. Remove the discard these three, and the remaining one is making a new cone, and then like this. Ultimately, you get a very small size of a laboratory sample, and then this sample is taken into the analysis. So, gross sample, a number of increment taken from a large quantity of a material to be analyzed. Bulk sample or lot sample, a large size representative sample actually. So this represent the whole is relatively small fraction. Composition similar to the matrix, and degree of heterogeneity of the whole sample. Laboratory sample, from all these practices, you get a very small size sample taken to the laboratory to the analysis, which is the representative sample of all the bulk sample actually. So this analysis sample, this laboratory analysis sample, this part of lab sample, this to be analyzed. This is the representative sample, which is very small in size. The part of this even small size is analyzed, and rest is stored for archiving and rechecking purposes. This analysis sample. Size of the sample is very important. So minimum amount of sample is basically required. That is sufficient for analysis. So for reliable, accurate, and reproducible results, you need a sample of a very small size, which is the representative of all sample. So this equation W is equal to this Ks divided by R square. So K is Ingham sampling constant, mass of a sample for 1% sampling uncertainty at 68% confidence level. We will discuss this confidence level for in our coming slide. What is confidence and relative standard deviation also. So with 68% confidence. So sampling variance is inversely proportional to the sample of size. Greater the sample of size, variance is small. Uh, with a large variance, the size of the sample is small. So, minimum number of sample, the number of individual sample increments needed to achieve given level of confidence in the results. So, as n is a number of sample, and s is a sampling variance. So, according to the Gaussian distribution centered around, so where it is giving a maximum, that is the number of samples to be analyzed. And sampling, how to perform a sampling. So the the if the individual sample do not represent accurately the population from which they are drawn, a population that we call the target population, then even a careful analysis will yield an accurate inaccurate results. So designing a sampling plan is a very important. So a sampling plan must support the goal of an analysis. A material scientist interested in characterizing a metal surface chemistry is more likely to choose a freshly exposed surface created by cleaving the sample under vacuum than a surface previously exposed to the atmosphere. In a qualitative analysis, a sample need to be identical to the original sample if there is a sufficient analyte present to ensure its detection. Then, how to perform a sample, how to get it. Natural nature of material is important. That what type of material is this? Is then a sampling from that material, and then the type of analysis and what confidence level you need, and the statistic, the relative standard deviation. What is the uh, what is the standard deviation you need, what is the accuracy, what is the precision you need, the systematic error, how minimum possibility to take in account. So separating the analyte from the interference is also a very crucial job to do. When analytical method is selective for analyte, analyzing a sample is a relatively simple task. For example, a quantitative analysis for glucose in honey is a relatively easy to accomplish if a method is selective for glucose, even in the presence of other reducing sugar such as fructose. So, coming to the different physical status of the sample. So, if the sample is in a solid form, the variability in sample matrix is the maximum in a solid form. So diffusion is a minimum in the solid form. So all these things you take it in account. So diffusion is minimum in this solid, but on the other hand, diffusion is maximum, and diffusion is maximum in gaseous, while diffusion is much more in liquid in comparison to the solid. So maximum number of sample to be max for a representative sample, because automatic mixing in solid is not possible, because in liquid or in a gases, so this automatic mixing because of this diffusion is possible, but in a solid you have to make a cone and then make it a flatten, and you make it first to grind your sample and then make it a homogeneous, and then make it a cone and divide it into two and four, and then a quarter, remove the three quarter, and one quarter again a cone. So this is so the because the size reduction is very important in this. And then a grape sample and auger sample, hand caught, etc. All these things you have to take in account. So in a liquid sample, there is a more diffusion in comparison to solid. So a more homogeneity is already there in the liquid form. So in comparison to solid state, so that is the sampling in liquid state is much easy. Pure liquid grape sample is a representative sample. Solution depends on the composition. So a number of samples to be mixed for replicate sample. Mixing is easy in liquid sample. Glass or plastic bottles are enough to take these liquid sample from your bulk sample actually. So this is we discussed this one. So the other one is a gaseous sample. So evacuated glass or plastic bottles are enough for gaseous sample actually. So a glass range or absorption train, these are used for a gaseous sample. A gaseous sample, it is not very easy to collect a gaseous sample in comparison to liquid, but that is more homogeneous, the gaseous sample, in comparison to a solid one. So then one of the other this thing you have to take in account transportation of this sample. Sample to be transported to laboratory according to the GLP and the QA program, uh, and must be refrigerated so that some other processes, some other chemical reaction, and some other chemical changes may not take place. Uh, and and you have to take these samples like means at ambient condition, pre-treated according to the requirement, what type of analysis basically you need to perform. uh, I will recommend these two books, G.D. Christian, Analytical Chemistry, 7th edition, John Valley and Sons, and Scooge and West, Fundamental of Analytical Chemistry, ninth edition, and I will recommend these two books. And we will discuss some more aspect of sampling in our coming lecture. Thank you very much.